All right, in this video we're going to introduce Jupyter Notebooks and the Python programming language. Now, before we get started with doing any sort of calculations, the first thing I want to talk about is the ability that you have to sort of talk about what your code is doing without it affecting anything at all, and that's called a comment. So in Python, we start a comment with a hashtag, and then anything on this line inside this little cell here, this is called a cell in the notebook, anything after this hashtag symbol on this line inside the cell will get ignored when we go and run our computer programs. If we want multiple lines for comments, well, one option is we have to start each of those lines with a new hashtag symbol. So while this is absolutely okay, it's not exactly the easiest and most efficient way to make multi-line comments. For that, we have two options. We can either use 3 double quotation marks and anything in between these 3 double quotation marks and these 3 double quotation marks. Anything in between there will be a comment. So rather than start each line with this hashtag symbol, we can instead write these triple quotation marks and triple quotation marks, and then anything in between them will be a comment. If we don't want to use triple, sorry, it's my dog. If we don't want to use triple, we can use single. The only thing you want to keep in mind is that if you start off with 3 double, you end with 3 double. If you start out with 3 single, you end with 3 single. So it's really nothing to be too afraid of. And what this will allow you to do is sort of write what your code is doing for not only others, but possibly even yourself if you were to come back to it after, let's say, a couple months. Now, the Jupyter Notebooks allow you to type in what's known as Markdown. You're not going to have to worry too much about that in here, but it does allow you inside these cells to write out any notes or even comments that you want that will tell you and others what your code is doing. And you're going to see that a lot in these notebooks. Now, if you notice here, when we click inside this cell, it says Markdown. If we click inside this cell, it says Code. So one of the disadvantages, in fact, one of the only disadvantages I can think of, is that sometimes when you want to be typing in code, you'll actually be in Markdown mode. So you can just switch it in this drop-down menu here, and then to run it, you just click on this little play button, and it runs it. So you can also use a keyboard shortcut by holding down Shift and pressing Enter or Return. So if I hold down Shift and press Enter, we get it to run as well. All right, so we're going to start by looking at some basic calculations, so stuff that you would have learned in elementary school, but we're seeing how to do it in the computer. So when performing calculations, you have the option of putting space around the operator. So here we have 5 plus 7. Notice around the plus, both before and after, we have space. So if we choose to do that and we run this cell, it's going to give us 12, which is what we would expect. However, you also don't have to put a space around the operator. So if we do 5 plus 7 here, we get 12. Now, if you put a space maybe after but not before and then run it, it's okay as well. So that should be okay. 3 minus 9, we have the dash that's to the right of 0. So we run this and we get what we'd expect, negative 6. For multiplication, we use the asterisk, which you can get by pressing Shift, holding down Shift, and then pressing 8. So you're going to use the asterisk for multiplication. So 7 times 2, if we run this, we get 14. So there's our output. For division, we're going to use a forward slash. So to calculate 9 divided by 4, we just type 9 forward slash and then a 4, which the forward slash is usually next to the Shift key on the right-hand side, right below the question mark. It's on the same key. So if we run this, it should give us 2 1/4, and it does. All right, so your first exercise for this assignment is I want you to calculate each of the following. So in this cell, you're going to type in 8 times 7 and then run the cell. So you can either press the play button or you can hold Shift and press Enter. And then for part B, I want you to do 15 divided by 3. So just a little bit of practice with some of these basic calculations. All right, next up, order of operations. Much like many calculators now, your Jupyter Notebooks and Python will do order of operations for you where it goes from left to right and evaluates any parentheses and exponents. Then going left to right, it will then evaluate any multiplication or division, and then left to right, any addition or subtraction. And remember, the parentheses will matter. So for this one, we have 5 plus 3 times 2. It's first going to take and multiply 3 and 2 together to get 6, and then take 5 plus 6 to get 11. And we see that's what we get. However, if we wrap the 5 plus 3 inside parentheses first, now it's going to evaluate the parentheses 5 plus 3, which is 8, and then 8 times 2, and it should give us 16. So exercise 2, just a little more calculations with order of operations. So part A, we have 4 times in parentheses 8 minus 9. And over here I have you should get negative 4. That's just to tell you what your answer should come out to be. So kind of like I have on the problem sets where I tell you what the answer should be so you know if you got them right. So if you type this into this cell and run it, it should give you back a negative 4. So you'll know you got it right if you got that. Part B, 1 plus in parentheses 2 minus 3, and then close the parenthesis and then divided by 4. And that should give you 0.75. So if you don't get 0.75, check your calculations. Also, don't forget, if you have a parenthesis that opens, you must have a parenthesis to close it. So whatever parentheses you have to open, you also have to have that many parentheses to close. Otherwise, you'll get an error message. So if we do this, it should give us an error message, and it says the opening parenthesis was never closed. So wherever we would have it, in this case we had it here, and everything's good. So if you see those red boxes pop up, those are just errors and warnings, and they'll actually give you a little bit of helpful advice as far as how to fix it, like, oh, you forgot to close the parenthesis, so go and find where you need to close it. All right, with exponents in Python, you're going to use double asterisks to indicate you're going to raise the value to a power. So for instance, to evaluate 5 to the second power, which we know is 25, we take 5 and then the double asterisks, don't put a space in between them, double asterisks and then a 2. So this is 5 to the second power, and if we run that cell, it gives us 25. Now, just like with regular calculators, if you want to square a negative number, you're going to have to put parentheses around the negative number before you raise the number to the power. So if we have negative 5 squared, it's going to do order of operations. So the first thing it's going to do is going to look at this as negative 1 times 5 to the second power. So it's going to do 5 to the second power, which is 25, and then multiply it by negative 1, which gives negative 25. And if we run this cell, we see we get exactly that negative 25. Versus putting parentheses around that negative 5 in parentheses, and then after that parenthesis, we then type in the double asterisks. That is negative 5 times negative 5, which is positive 25. Okay. So for exercise 3, a little bit of practice with exponents. So first up, 9 to the 4th power, you should get 6,561. So type what you have to type into here and then press play or shift and return, and you should get 6,561. Negative 7 to the 6th power, you should get 117,649. So type that negative 7 to the 6th power in here. And then part C, a little combination of exponents and addition here, 3 squared plus 4 squared, and it should result in 25. So see what you have to type into here, run it, and it should give you 25. If it did, you got it correct, and I hope that you did. All right, variables. So in algebra class, when you first learn about variables and they start talking about how letters can be used to represent numbers, it can get a little bit overwhelming. However, now that you're a little bit older and hopefully a lot wiser, you've dealt with variables so much that they're not as scary as they used to be. And variables for a computer are the when does anybody actually use this stuff question that you may have asked in the past. Variables are very useful in computers and running calculations and codes and programming. So as far as Python is concerned, we only have a few rules for naming variables. First, they must start with a letter, could be capital or lowercase, or start with the underscore character, which is found by hitting Shift and then the button to the right of 0, and that should give you your underscore. It cannot contain a space after the first character. So if you took your first initial and then your last name, you would not want to put a space in between the first initial and the first letter of your last name. You can use the underscore. It's very common to indicate spaces. Variable names are case sensitive, so HELLO, all lowercase, is not the same variable as capital H and then ELLO, or this weird jumble of lower and uppercase letters. So all three of these, this hello, and this hello, would be considered different variable names. Although I would advise not naming all of your variables with this crazy way of doing it here. All right, so first up we have x equals 4. So what's going to happen is it's going to take the value of 4 and assign it to the variable x. So we type it in. Now we want to run the cell, and it's good to go. So once we define that value of x as 4, we can then use that value over and over again for x as much as we like. So for instance, 9 times x, it's going to substitute 4 in for x and give us 9 times 4, which is 36, just like in a class, like especially past algebra classes. Y equals -2, we're going to run this cell, and then 8 plus -2 should give us a 6, and it does. Now let's say we need to calculate the distance between two x coordinates. We have x1 and x2, where x1 has a coordinate of 9, x2 has a coordinate of 16. Well, we could define everything in separate cells, but we can also define everything in one or even two cells. So here we have x sub 1, and typically we also use underscores for subscript notation in going with these kinds of problems. There's other ways to do it as well. But x sub 1 is 9, x sub 2 is 15. So we're going to start by running this cell. And now if we calculate x sub 2 minus x sub 1, it's going to take that value for 15 and subtract this value of 9, and 15 minus 9 should give us 6. And yay, it does. Now, we could have also done everything inside of one cell. So for instance, right here, we have everything inside one cell. I will let you know, though, if you have multiple calculations, like here we have x2 minus x1, but let's say we wanted x2 plus x sub 1 as well. So if we were to type in x sub 2 plus x sub 1, Jupyter is only going to evaluate the very last operation inside of a cell. So it's still only going to look at x2 minus x1, which again was 6. So if we wanted x2 plus x1, we'd either have to make that the last one in the cell, or we'd have to run this in a separate cell, which you can always get by inserting a cell below. But for right now, it's okay. And what's nice about computers is, as opposed to like your typical math class, is we can use better and more descriptive names for our variables rather than just x or y or anything like that. But having better names, one of the biggest advantages is it gives you a better idea of what they represent. So for instance, here we have x equals 4. Well, what does x represent? It's really not very clear in this context, in this setting. However, if instead of x we use a word like radius equals 5, then if I were to look at this line of code here, like in 5 months or 6 months or a year, I would know that this is a radius perhaps of a circle. So in this case, we have a radius value of 5. We can store that value of 5 in for the radius variable, and now we can use that radius value to calculate the area of a circle, 3.14, approximately 3.14 times the radius raised to the second power, and when we do that, we get 78.5. And then if we wanted to change the radius, we could just change this value here, run this cell, and it would give us a new area of the circle. Now, it's important to remember that the computer knows that the value of x1 is 9, the value of x2 is 15, the value of radius is 5, but if we try to use a value without defining it first, it's going to give us an error message because the computer doesn't know what we mean. So for instance, here we have 1 plus w, but we never once defined what w was. We said x is 4, y is -2, x sub 1, x sub 2, and radius, but we never defined w. And if we try to evaluate 1 plus w when we didn't say what w was, we're going to get an error message. So name W is not defined. Again, this big scary red box means there's just an error. And in this case, it doesn't know what you mean by W because unlike radius, where it tells you you're telling it it's 5, you haven't told the computer what W is. All right, so our next group of exercises here, exercise 4A, I want you to define a variable z to be equal to 10. So type that in here and run it. Then in 4B, I want you to define two variables, base and height. And if you want to insert more cells, you can, but you can actually do this all in one cell. I want you to set the value of base variable to 11 and the value of the height variable to 10. And then I want you to show the result of calculating base times height, and you should get 110. So I need a base variable, a height variable, and then I need to see what your calculation answer is and what you type in for that calculation with base times height. All right, the last part of this video deals with functions, something we've talked a lot about in previous math courses. And just like they're very powerful tools that help us in math, they're also very powerful tools that will help us in calculations with computers and programs and code and all that good stuff. Now, there are a couple ways that you can work with functions and put functions in the computer in Python. We're going to stick with this way where we declare the function using the define or DEF keyword. So a keyword is basically a word that Python and Jupyter notebooks will reserve and set aside where you can't use a variable name DEF. So you're not, if you try to use DEF as a variable name like we used radius earlier, it's going to give you an error message. And then we're going to name our function and then put what a variable or variables are inside parentheses. So in this case, like your typical f of x that you've seen a billion times, the name of the function is f, and then the variable that we're going to use is inside parentheses, x. Now, unlike in math class where you get a lot of leeway to write stuff on your paper, Python is very particular about what we do next. After we close the parenthesis here for this x, we need to use the colon, which is to the right of L, so you get it by hitting Shift and then the button to the right of L, and then press Enter or Return. And it's very big. Python is very big on indentation and the way it looks visually. So you can use tabs or spaces, but you must indent the next line after you hit Enter or Return. Now, Jupyter Notebook will automatically indent it for you, which is fine, but if you were using, let's say, a text editor or some other program, it might not do that. So it will update, or it will rather indent the next line for you. And you need to be consistent with your indentation. So if you have more than one line for your function, maybe it does a lot of different things, you need to have the same amount of space for indentations every time. So you can either you hit the space bar a couple times or you can hit the tab key, but you have to be consistent. Otherwise, you're going to get a big scary red box and it'll say indentation error. Then you're going to type in the keyword return followed by what the function is to do. So that's a lot to take in. So let's see a basic function example from like math class. So we have the function below was f of x equals 2x. So this function's whole job in life is to take whatever you give it and multiply it by 2. And when we define the function, because we have a 2 and an x, we have to use the multiplication asterisk in between. If we just do 2x, where we just don't have any time symbol in between, I believe it's going to throw us a syntax error message. But in any event, the defined keyword DEF, here it is. Notice it kind of turns it, the notebook turns it like bold and green. So it'll do that with the keywords like return, bold and green. Here's f of x, here's our function. And then an equal sign, here we use a colon. We saw in class on the TI calculators, we use colon equals. So everything's kind of somewhat related. And then we press enter, and then the next line, we're going to type in the word return, and then we're going to return what's on the right-hand side, 2 times x. So we're going to run this function. Everything's good. We didn't get any error messages. And so now if we want to evaluate, let's say f of 5, we just type in f parentheses 5, and it should give us 2 times 5, which is 10. And while we do a lot of f of x and g of x and things like that in math class, Just like in computers and programming here, you can use better names for your variables. You can also use better names for your function. So let's say we have, we'll go back to our area of a circle function. We could say f of x again, but a better name would be circle area. And again, notice that you can either use the underscore symbol, or if you want to, you can just make it all one word. Some people like to capitalize every new word and keep the first word lowercase. This is called camel case, C-A-M-E-L case, but you don't have to worry about that. So I'll just keep it like this since that's how it is. And then it's the input is going to be a radius. So again, we can use a better name than x, colon, and then we're going to return 3.14 times the radius squared. So we're going to run this. Otherwise, if we don't run it, it's not going to know what to do here. And then circle area of 7 is going to tell us what the area is if the radius is 7. So 3.14 times 7 squared is 153.86. Now, you can even put comments inside or outside your function to describe what it does. So here we have a comment in our function. So it tells us it calculates the area of a circle. And if you ever decide to study computer science or programming later, I'm going to strongly advise that you write comments as to what your functions do, because if you step away from it for a while and then come back to it after a few months, you might not remember what it does. You might in this case, because it's the name of the function and the input value, the name radius, but it's not a guarantee all the time. Notice, though, these are both indented the same amount of space. The same amount of space. So if we do this, again, the computer's going to ignore what's on this comment line. So that's just for us to see. And then circle area of 7. Again, 153.86. And we can also indicate what our value inside parentheses is here by using the same name that's in our function definition inside the parentheses. So if we do circle area, and then since we're calling this radius, if we do circle area and then say inside radius equals 7, it's the same thing as evaluating circle area of 7. So we should get 153.86, and we do. If you have more than one variable, like you're calculating the volume of a cylinder, where you look at it's based on the radius and the height, pay attention to the order in which you have these two values. The radius is first, the height is second. Here's our formula, pi, 3.14-ish, times the radius squared times the height. That'll give us our volume of a cylinder. And then if we're looking at cylinder volume 5, 7, the 5, the first number before the comma here, 5 is the radius. And we can also do the same thing here like we did with the circle area. The 7 is the height. So this will calculate the volume of a cylinder with a radius of 5 and a height of 7. It's about 549.5. Here we have same thing. Me personally, I like this because it reminds me of what these numbers are. So, sometimes instead of radius and height, we could have done height and radius, kept everything else the same, but this gives us a better description. So you have the option. The option is up to you. All right, exercise 5, we have a function f of x squared plus 4x minus 1. I want you to define the function, so you can do that here on this line, and then go ahead and run the code. Then I want you to evaluate f of 3 in this cell, and then run it, and you should get 20. All right, as an optional challenge exercise, I want you to define a function that's going to calculate the average rate of change of a function given two input values for x. So you might have to have one cell here for the function itself, like x squared plus 4x minus 1. So whatever function you're finding the average rate of change of. And then you might have to add another cell and come up with another function that will calculate the average rate of change for this function. So it's an optional challenge exercise. You do not have to do it. The other problems, though, the other exercises, you will have to do those. So, all right, that about does it for this video. Thank you for watching. I'll see you later.